How do you get a language model to do what you want? You write a prompt. It's almost right, so you go back in and add a line. Still off, so you tell it it's a world-class expert. You put a word in all caps. Maybe you promise it a tip. We call this prompt engineering, though there's precious little engineering in it. It's mostly nudging words by feel until the output looks good. There's a framework out of Stanford that looks at all of that and asks a blunt question. Why are you writing the prompt at all? Their bet is that you shouldn't. You say what you want, and a compiler writes the prompt for you. Program, don't prompt. Those tricks, the expert flattery, the all caps, the promised tip, sometimes they help, sometimes they do nothing, and you can't tell which, so you hedge and keep all of them. Do that long enough, and your prompt is a pile of little rituals you can't explain, half of it probably dead weight. It's basically superstition, chucking words at the model and hoping the rain comes. DSPy's whole move is to make that systematic. Stop guessing which words help and start measuring. Let the score pick the prompt, not your gut. So what do you write instead? Almost nothing. You write the shape of the job. A support ticket goes in, an urgency level comes out. Inputs on one side, outputs on the other. That's a signature. Nowhere do you write, "You are a helpful assistant," or pile on the all caps. And say you want the model to think step by step before answering. You don't go write a thinking prompt. You swap one word, predict for chain of thought, and DSPy rewrites the instructions underneath to make it reason first. The how is a dial you turn, not a paragraph you write. But a shape isn't a prompt. Somewhere, somebody still has to write the real words and send them to the model. That's the part DSPy calls compiling, and it wants two things from you. A handful of examples, questions paired with the answers you'd want back, and a metric, a little function that scores the output, high when the answer's right and low when it's wrong. Give it those two things, and you step back and let it cook. The way it does that is plainer than the word compiler suggests. Say the task is grade school word problems. DSPy runs the model on a stack of training problems and watches which ones it gets right, and on those it keeps the whole worked solution, every step the model took to get there. Then it picks a few of them and pins them to the top of the prompt as examples. And the key word is few. Not the whole pile, a few. The prompt only has so much room, so it can't smuggle in an answer for every question. And the questions you actually care about are new ones it's never seen. So this isn't memorizing the answer key. The real job is finding the handful of worked examples that teach the underlying move well enough to carry over to problems that aren't in the set. Good examples generalize. Bad ones just overfit. Picking the few that transfer is the whole game. And plain as that is, it works. In the first paper, that grade school math task climbed from 24% right to 65%. Same model, nothing fine-tuned, just the examples it picked for itself. It beat the examples a human expert would have handpicked by more than 25%. And the upkeep gets easy. New model drops, you don't rewrite a thing. You recompile. Fresh prompt, tuned to the new model, while you go get coffee. There's a ceiling here, though. Look at what the optimizer can actually see. A single number between 0 and 1. Pass or fail. It knows the answer came out wrong, but it has no clue why. Picture grading 1,000 exams with nothing but the final score. Not a single note in the margins. You can line the students up worst to best, but you can't teach a single one of them anything. The signal's too thin to fix what's actually broken. So in 2025, the same crew changed what the optimizer gets to look at. Don't hand it a score, hand it the crime scene, the whole failed run, every step the model took and the exact error it hit. Then point a second model at the mess and tell it to read the whole thing and write down what went wrong, in plain English, the way a person would. They call it GEPA. So instead of a flat 0, the note comes back as a sentence. You blew it because you copied the season straight out of the input instead of working it out. And watch what it does with that. The first trick only ever swapped which examples to show the model. GEPA goes after the instructions themselves, the actual wording of the task. It reads its own note and edits the rules. Add a line that says, work the season out, don't copy it. Then it runs again, keeping a whole bench of reworded prompts alive and breeding the ones that work. And it never retrains the model. The weights never move. Everything that gets better in the words of the prompt. And reading the mistake beats counting it. Not by a little. They ran GEPA head-to-head with reinforcement learning, the big GPU-hungry method you'd normally reach for, and it won by up to 20% on as little as 1/35 the tries. Hundreds of runs instead of tens of thousands. No GPU farm, not a single gradient step. Just a model reading its own notes, beating the brute force machine. And the idea didn't stay in the lab. When OpenAI shipped automated prompt optimization inside its new agent product, the people who knew GEPA took one look and called it the same method. So this should be everywhere by now. It promises better answers with no fine-tuning and lets you swap models for free. And yet, people are split on it. Plenty of developers post that they flat out love the thing. But pull up the threads and the most upvoted take is almost gentle. The concept is really interesting. The framework you actually install is, their words, a tad immature. There's a whole popular thread that's just somebody asking point blank, if it's so great, why is nobody using it? The idea is clean. The thing you have to pick up and hold is a different story. Because the hard part didn't vanish, it just moved. It used to live in the prompt, now it lives in the grader. And the grader will turn on you the second you get lazy. Score answers by length instead of quality, and the optimizer won't argue. It'll happily dig up a prompt that writes long, confident answers that are completely wrong, and hand you an A. It did exactly what you measured. You just measured the wrong thing. And remember the promise. Forget the wording, just declare the shape. The wording sneaks right back in. The names you pick for those fields quietly move the output. Call a field request, or call it research request, and the same model hands you different answers on the same task. The thing you were trying to escape is hiding in your variable names. And when it breaks, the prompt it built you is a giant machine-written wall of text, all bent around your examples, faintly alien. You're now debugging something you didn't write and can barely read. Here's where I come down on it. The idea is right, and it's not going away. A prompt was never a handcrafted incantation you polish by feel. It's something you pin down and improve by measuring, like everything else we built. One engineer nailed it. Any AI system complicated enough ends up with a half-built, buggy version of DSPy stuffed somewhere inside it, whether the people who built it ever heard the name or not. They keep rebuilding the parts because the parts are right. The catch is the object itself. The thing you install is fiddly and easy to get wrong, even while the idea behind it holds up. The beautiful idea and the painful object are the same project, and right now, you can feel every inch of the gap between them.